Hello, today I'm going to do a test of the SM5A. A stands for one length of 48 centimeters. So I'll place this now in my pond where there is ice. I'll try to find a hole to put it in and let it stay until the ice melts, and then we will look at the data.
Since the pond was frozen solid to the bottom, I had to put it through a hole in the ice. I could take away one of these dead plants, and that's where I put it. And I decided to leave it until the ice melts, so we can see what happens. But first, I'll show you some environmental images before we go and look at the result. While we are looking at the instrument here, let me tell you that it has a sensor that's 48 centimeters long, and it's possible to combine more than one, so we can make it even longer. And since it works both above and below water, because it measures each level individually now, which the old ones have not, it can be used. And we are going to look at that now in the data from this deployment. So pay attention to what happened. The ice melted now.
At some point of time, the ice melted and the instrument fell over. So let me see if I can recover it now, and we can see that it's facing with the sensors down. Luckily it has an accelerometer up in this end, so we can see from the data when it fell over. So let's go to the lab now and see what it has recorded.
Here we have the data now imported into the Sedimeter app. And up in the left corner, we can see the Sedimeter plot with straight measurements selected. These are direct backscatter. The light is sent out from and received at the same level, and then the background light is subtracted. So let me show you right away one of the implications of this. Up here, the background light was saturated because the sun was shining on it, so it shows 0, even though it's actually a lot of signal. Now, down here in the bottom left, we have the oblique sent out from one sensor and received on the adjacent sensor, and again subtracting the background. Up to the top right, we have a new channel in SM5, and this one is 2 centimeters apart. It sends it out from one level and measures it on 2 centimeters away, not the nearest neighbor, but the next. And additionally, it does not subtract the background light. And the purpose of that is to be able to detect the difference between water or sediment and air. So here we have sunlight, and this is night. In the night, there is total reflection. In the daytime, there is sunlight. And the top and bottom lines, there is no total reflection. There is no measured level, obviously, because it measures 2 centimeters apart. So there is no sensor available for measure that. And then the bottom right, there is all 3 of them are shown together. And there is another way to show that all 3, and that is in color with an RGB plot, like here, where we have the direct backscatter as red, the oblique as green, and the 2 centimeters away and the ambient light as blue. So in this case, we see daylight sunshine as blue, night as kind of pink here. And this night there was more blue, probably because it was a very cold night with frost. Let's look at the temperature, by the way. Here you can see, yeah, the temperature went below 0. There was a lot of frost that night. So let me see if I can zoom in. Here we see it better. It went down to well below 1 degree. Since the top of the sensor where the thermometer was in air, it measured that. Probably it was even colder, but that was the temperature the sensor had. So while we're at this graph, what we see here, the red, is the level, the bottom level interpreted. In this case, it's actually the level of the ice. And the green is the temperature. And it went up when the sun was shining. The sensor, the temperature of the sensor itself was up to over 17 degrees. And then the tan color here is tilt. This one here I moved it. That's why there is a change here. I'll get back to that in a moment. So it was at 4 degrees, and here due to the melting in the sun, the ice started to melt away, tilted over to 10 degrees, and then gradually more and more until it fell over. And let's go back to this all data. So we have the blue line also here. This is new water level. And it reports the water level in centimeters only. And as you can see, it's not that precise as the bottom level. And here where the sunlight is shining, it actually was a bit blinded. But at least you get an idea of the water level. And this is just one measurement every 5 minutes. It's possible to make burst measurements, which means every time it's time to do a measurement, it takes a number of measurements, maybe 1 second or 5 seconds apart. So here we can see it fell over, tilted first at 70 degrees, and then all the way to 83 degrees. If we now go back to this one, we see here is where it fell over. First, the ice was melting down here, and then it fell over, and we have the sensor in water. It's totally black here. And then it fell the last degrees, and it came to rest on the vegetation, which we see here. So this is up in air, and here there is water, and here this is actually ice, and this is below the ice here. And over here it was standing in the vegetation, so this is more or less what it would look like if it had been in sediment. Both the red and the green lit up, so it turns yellow. So let's go back and check this out here. Here we have the direct backscatter, very strong. The oblique, very strong also. This not so strong, because there is not a so strong signal. There is no direct reflection underwater or in ice. And the signal is not strong at all, so that's why it gets yellow there. Whereas where we're up in air, you have a stronger signal of this, relatively speaking. So that's how we can interpret these signals, and I think I mentioned, we have the near-infrared background light also, it's possible to see, and the vibration in milli-G, and that's taken from the accelerometer. It's possible to trigger this with the accelerometer, by the way, to make a conditions-based monitoring. And there is a turbidimeter, which was up in air here, so I don't show it. But when it's totally underwater, this is a good quality turbidimeter. So that's it. I hope you liked the video, and please like and subscribe, and see you next time.